Today we will let's look at the response of parallel RC circuit to sawtooth current input. Consider an RC circuit. Resistor is 1 kilo ohms, capacitor is 500 nanofarads. Input is a sawtooth current waveform with time period equal to 1 milliseconds. Now, since R and C are in parallel, the voltage seen across resistor and capacitor will be same. We want to find the current flowing through the capacitor and resistor and the voltage across capacitor also, which will be same as voltage across resistor. Now, the voltage across resistor can be calculated as follows. At 0 microseconds, voltage across capacitor is equal to V in into 1 minus e to the power minus t by RC, where V in is equal to I in into R. At 5 microseconds, the input current will be available and the capacitor starts charging, and the charging equation is given as follows. TR here is real time, which is equal to 5 microseconds. T start is equal to 0 microseconds, which is equal to 5. TR minus T start will be 5 microseconds. At 10 microseconds, the voltage across capacitor can be calculated using the following equation. TR here is 10 microseconds and T start is 5 microseconds. We can see that voltage across capacitor is equal to V in into 1 minus e to the power minus T real minus T start by RC plus VC of 5 microseconds. Capacitor would have charged to some voltage level at 5 microseconds into e to the power minus TR minus T start by RC. I in here is calculated as I peak into T real by T period. Now the amplitude of this sawtooth current input is 1 amps, which and hence I in is equal to 1 into T real by T period. T period is 1 milliseconds. Similarly, at 15 microseconds, the voltage across capacitor can be calculated as follows. Voltage across resistor is equal to IR into R. Current flowing through the capacitor is equal to I in minus IR, and current flowing through the resistor is equal to VC by R. Now on plotting these values, we can see how the current flowing through the capacitor, voltage across the capacitor and current flowing through the resistor looks like. So as we saw earlier, the input is a sawtooth current input and between 0 to 1 milliseconds is its time period. So it increases up to 1 milliseconds and at 1 milliseconds it drops down to 0. That is why we can see a current spike here at 1 milliseconds. Since there is a drastic change in the input current, we can see the current spikes at 1 milliseconds. And the voltage across the capacitor is seen as follows. It increases, or the capacitor charges up to 1 milliseconds, and at 1 milliseconds as the input drops to 0 it discharges, and as and when the input current increases it starts charging and the voltage seen across the capacitor also gradually increases. We can see that it doesn't fully discharge once the input current drops to 0 because there is no enough time available for the capacitor to fully discharge, and hence with the initial voltage it starts charging again and increases. This is the input that we are feeding to the parallel RC circuit. I in here is equal to, like mentioned earlier, I peak into L by T period. Voltage across capacitor is calculated as follows. At 0 microseconds it is equal to V in into 1 minus e to the power minus T by RC, and at 5 microseconds it is equal to V in into 1 minus e to the power minus T real minus T start by RC. T real minus T start is same as 5 microseconds. And on plotting these values, this is how the voltage across capacitor looks like, and the current flowing through the resistor is equal to VC by R, and current flowing through the capacitor is equal to I in minus IR. On plotting all these values, we can see how the graph looks like. Let's simulate this and check. On simulating this is the input current that we are feeding to the parallel RC circuit. This is how the voltage across the capacitor looks like. We can see that once the input current drops, it starts discharging, but it doesn't discharge fully, and there will be some initial voltage and it starts charging again once the input current is available, and this is how the current flowing through the capacitor looks like. Here is the summary. We can see how the sawtooth current input has transformed the current flowing through the capacitor and the voltage seen across the capacitor and current flowing through the resistor. If the time constant of RC circuit is comparable to input's time period, then it will not resemble the behavior for sawtooth current input. Thank you for watching this video.